Alright, so now here in 4.2, now that we have a better idea of what just the generic sine and cosine curves look like, we're going to take that one step further and actually start moving it, translating it, extending it places on the graph. Okay, so the first kind of transformation we're going to talk about is called a vertical shift. So if you've been in Algebra 2 already, or you've done some nice graphing, these transformations are going to be very similar to the functions that you've already done. A vertical shift, if you remember in graphing like the absolute value function, or cube root, square root, rational functions, things like that. When we add a constant or subtract a constant to the outside of our function, this shifts the graph vertically. Vertically meaning up or down. Oops, let me pick a different color. So vertically, remember, is up or down. Okay. The nice thing about a vertical shift is that we're going to actually do what it says. So if it's positive, it's going to go up. If it's negative, it's going to go down. Okay, that says that down here in our vertical shifts at the bottom of the screen. If our function is being added by a constant, we go up. If it's being subtracted, we go down. Okay, and this will stay true for a whole lot of our functions that you're going to graph through your math career. Any sort of constant being added to any sort of function will usually move it up or down depending on if it's positive or negative. Okay, so we've mentioned before this odd versus even function. So an odd function, basically what that means is that if we plugged in a negative x into the function, that would be the same thing as just making the function negative on the outside. The even values, if we plugged in a negative x, it wouldn't change anything. It's as if we just plugged in a regular positive x there. Okay, so back to our transformation. So again, if we're adding some sort of constant, we're moving the function up or down. If we have a vertical shift, the big thing to know is that this will change your midline. Changes your midline. Okay, if we don't have a vertical shift, then the midline is always going to be just the x-axis. But if we're shifting it up or down, those things are going to change. Okay, our next transformation is what we call a phase shift. Okay, so this would be when we add or subtract something inside of our parentheses. Like we have sine of x plus 2 or cosine of x minus 4. This tells us to go to the left or to the right. If you want to call this a phase shift or horizontal shift is what it's called a lot of times, but this is going to move it to the left or to the right. For it's a little different. Okay, we're actually going to do the opposite of what it says. So if we were going to move in a positive, generally we would tend to want to move to the right. We're actually going to move to the left. And if it's a negative shift, we are going to want to go to the left, but notice we're going to actually go to the right. Okay, so it's the opposite. Same kind of idea when you're graphing like your absolute value functions or square roots. This is the same. You're following the opposite for a horizontal shift. Okay, so again, this is called a phase shift. So you'll see it as a phase shift, or if you want to say horizontal shift, that's fine too. This is how far left or right the function moves. Okay, so if we were given the function, which a lot of times we are, let's say our function is the sine of 2x plus 4. Okay, we know b would be 2. We learned that in the last video, that b is always the coefficient on x. And then c, our constant, is 4. Okay, that's the constant that's being added or subtracted. It's a little trickier because usually we would just want to say, okay, plus 4. That means we're going to go opposite direction, so left 4. But it changes, okay? To know what our phase shift is going to be, we actually take C over. and that tells us how far we're actually moving. So we know C is 4 and B is 2. So 4 divided by 2 is 2. It's a positive 2, so that means to move left. Oh, goodness. We're actually going to move to the left 2, our phase shift. Okay, so we can't just take this constant as it is unless B is 1. Okay, so we always have to plug it in if, it's always just good to plug it in, but especially if B is not 1. Okay, I'm going to kind of put it more together. Looking at all this stuff from amplitude to period to phase shift to vertical shift to all that fun stuff. So if we start with the equation, y equals 5 times the cosine of 4x plus pi plus 3. Okay, just made that equation up. Okay, so let's kind of break this down piece by piece. So the 5 outside of the cosine, out front, is going to tell us our amplitude. Okay, that's going to tell us how tall the graph is going to go from our midline. The period, if you remember, is 2 pi over b. B is the coefficient on x4. So this would simplify to pi over 2. So the period, remember, is how long does it take to get through one full cycle. So if we traveled from 0 to pi over 2, we would get through one full cycle of sine or cosine, depending on what we were looking at. Okay. Now we have a plus pi on the inside. So if we have anything being added or subtracted on the inside of the parentheses, this is going to tell us a phase shift. It's going to tell us how to move to the left or to the right, a horizontal shift. Okay, so we figure this out, as you see above, C over B. C is our constant, that's pi, what we're adding. B, we already figured out 4. Okay, so we can't simplify pi over 4. We don't want to leave it as a decimal by any means. And since it's positive, remember we do the opposite. So this is actually we're going to go pi over 4. And then last but not least, we have this plus 3 here on the outside. Anything being added or subtracted, either on the front or the back, but being added or subtracted to our function, is going to be a vertical shift. It's going to tell us how to move up or down. Since it's positive, this is going to go up 3. Okay, so not even graphing the function. If we just have the function, we can assume all of these different transformations are going to happen. Okay, so let's kind of put this all together and kind of color code this a little bit better for ourselves. Okay, so remember, k, whatever we're adding or subtracting to the entire function. This is our vertical shift. Okay, A, it's kind of nice. It already starts with the letter A. A is going to be our amplitude. Okay, whatever being multiplied to the outside of the function. Okay, next up is B. B is going to affect the period. Okay, this is technically just called the coefficient of x. Okay, it determines our period. Okay, which is 2 pi over b. Okay, so if you know the period, you can also use that to find b if you're trying to write the equation, but the period equals 2 pi over b, whichever one you have. Okay, and then last but not least, we also have, if there is a constant being added to x inside of the parentheses, this is going to be called a phase shift. Okay, if you want to call it a horizontal shift, that's fine too. Okay, it's telling you how to move left or right, and remember we're doing the opposite sign here. The opposite sign. So if it's positive, you're going to move to the left. If it's negative, you're going to move to the right. For vertical shift, you do exactly what it says. Okay, so I'm going to put this down here too. Your phase shift, the equation to figure out how far you're moving is C over B. Whatever that constant is over your coefficient of x. Okay, so even though this says sine, all of these still stay true for cosine. It's just, we're just going to write it out for one though. Okay, but everything stays the same. Okay, and then here's just some more information, kind of keeping it all together. But the biggest thing is I would keep this up as you're starting to write your equations.